Hello everyone, I'm Matheus Lacerda from the Federal University of Paraná in Curitiba, Brazil, and I'm so glad to do this oral presentation on the 10th International Workshop on Advances in Cleaner Production. This work has the title Comparative Life Cycle Assessment of Single-Use Plastic Bags Produced from Renewable and Non-Renewable Bases, and the authors are Matheus Lacerda, Marcel Mariano Correia Maceno, and Michele Rigoni Spia. Single-use plastic bag has become an item present in everyone's life, but they generate a large amount of waste because they are only used once. The annual consumption of the single-use plastic bag is between 500 billion and 1.5 trillion of units worldwide, provoking a significant environmental impact, especially because of the petrochemical raw material extraction process and the incorrect disposal of the single-use plastic bag in the environment. For that reasons, researchers are always looking for a new material that can replace that petrochemical polymer to try to reduce the environmental impact in the use of the single-use plastic bag. And one promising alternative is the raw material from renewable sources. But to measure that environmental impact of each one of the sources, we'll have to use some tool. And the life cycle assessment tool is one that are accepted worldwide to measure the environmental impacts and are defined by the International Standardization Organization with two standards. And these standards are the 14040 and 14044. And with all of this in mind, these articles aims to answer the question, are single-use plastic bags produced from renewable polymers competitive in the environmental impact compared to plastic bags made from petrochemical polymers on the market? To answer this question, the first thing we have to do is to define which polymers we'll be using. Starting with the non-renewable polymers, we use the high-dense polyethylene and the low-dense polyethylene because they are the most used in the productions of the single-use plastic bag. For the renewable polymers, we use a new recipe of thermoplastic starch developed by the Federal University of Paraná in partnership with the State University of Londrina. So, with the definitions of the three polymers, we can start assembling our life cycle assessment study. The first step of the study is the goal and scope definition. Starting with the goal, the intentional application is to compare the environmental impacts of the single-use plastic bag produced from high-dense polyethylene, low-dense polyethylene, and thermoplastic starch. The target audience is the academic community and industries, and the reason is to identify which polymer has the lower environmental impact. In the scope, the functional unit is to carry goods at the store to our home. The functional unit is to take 4.5 kilograms of shopping loads. The reference flow is 1 bag for the thermoplastic starch and 0.9 bag for the high-dense polyethylene and the low-dense polyethylene. These values are different because the petrochemical bags support a higher shopping load than the thermoplastic bags. So we have to choose one value and the reference flow rate has to be adjusted. And the system boundary is granular starting from the extractions of raw material until the final disposal at landfill. And for the life cycle inventory, we use the database from EcoInvent version 3.7.1, and we choose the evaluation method was recipe 2016, and we use the CIMAPROV version 90.2.0.1 to perform the life cycle assessment simulation. After we complete the previous step, a life cycle inventory could be assembled. Here in Table 1, we have the short life cycle inventory that was used in this work. In the first column, we have the materials and the process. In the second column, we have the corresponding name on EconInvent database, and the third column has the quantity in each one of the steps in the process. For the productions, we only consider the extrusion process because it's the most impactful process. And then, in the end of the life, all the polymers go to a landfill. From the life cycle inventory shows in the table 1, it was possible to assemble the inventory in CIMA Pro to evaluate the impact assessment using the recipe 2016 in the characterization model. Here in table 2 shows the impact indicator value per sectional unit. As we can see, the thermoplastic start has the biggest environmental impact in 11 of the 18 impact indicators. The low density polyethylene has the biggest impact in 7 of the 18 impact indicators, and the high density polyethylene is the polymer with the lower environmental impact. It's important to mention that the thermoplastic start is the only polymer that has a positive impact in the mineral resource scarcity against the low density polyethylene and the high density polyethylene. As you can see, the values of the impact are well distributed between the thermoplastic start and the low density polyethylene. So it's not possible to say which polymers has the high environmental impact, because the results here present only show how the impact indicators behave, not make it possible to distinguish which of the three polymers has the low environmental impact or the biggest environmental impact. For that reason, it's necessary to measure the intensity of the potential distribution of each environmental impact category that we measure by the normalization of the process that we will show in the figure 1 in the next slide. Here we have the figure 1 that was obtained by the normalization of the process using the recipe 2016, and we have one indicator that the most impacted life cycle assessment of the single-use plastic bag. That indicator are the human carcinogenic toxicity, and we have a great difference between the three polymers in that indicator. The indicator that the polymer, that has the high environmental impact is the thermoplastic starch, followed by the low density polyethylene, and with the lower environmental impact we have the high density polyethylene. So from the normalization we can say that the lower environmental impact is the petrochemical polymer high density polyethylene, and the high environmental impact is the thermoplastic starch. So to complete the presentation, we have the final considerations. The results demonstrated that the single-use plastic bags produced from petrochemical bases, in the case the high-density polyethylene and the low-density polyethylene, has a lower environmental impact when compared to the thermoplastic starch. But it's worth mentioning that the results shows a big environmental impact for the thermoplastic starch, because they use a large mass in the productions of the single-use plastic bag. Because if we compare the same mass of the polymer to produce the single-use plastic bag, the thermoplastic starch has a lower environmental impact, but the plastic bag don't support the same load of purchase. So to complete the presentation, it's worth to mention that only the partially life cycle assessment of single-use plastic bag was made of the 3D polymer, and is not conclusive to state that the petrochemical base has the lower environmental impacts when compared to the biological base. For the reason, a deep and more detailed life cycle assessment study should be performed to do that statement. So this is the considerations of this work. So to end this presentation, here we have the reference that was used to make this work. And that's all. Thank you so much for watching this presentation. Any doubts, you can send me an email at Matheus_MTL@hotmail.com. And I say again, thank you so much for watching this presentation. Bye bye.